Okay, ladies and gentlemen. Now, last set of questions. I'll be quiet and leave you alone. So, particle moves along the line x-axis. Its position, well, x of t, is t over 1 plus t squared. So that's position. Now, to be picky, I have to say t is greater than or equal to 0. X is in meters. Now, three questions for you. When is the acceleration equal to 0? First question. Second question. I want you to graph the position, the velocity, and the acceleration graphs all on the same axis for 0 to 4 seconds. Okay. Once you do that, the tough question, when is particle speeding up? What time is it speeding up and slowing down? So first things first, give me the acceleration. When is it 0? And do the graphs for me. And of course, just a graphing calculator will do that work for you once you get the equations. So pause the tape, figure out when the acceleration is 0, and draw the graphs, then come back and compare mine to yours, and then we'll talk about part C, speeding up and slowing down. So pause the recording, please. Okay, welcome back. So acceleration is 0. So let's see. Going on, x of t is t over 1 plus t squared. So we have to find the velocity. X prime. Now, I'm going to use a chain rule just because I find it easier. One denominator, I don't have to combine terms at the end. 1 plus t squared times 1 minus t times 2t over 1 plus t squared squared. So that's 1 plus t squared minus 2t, 1 plus t squared squared, which is t squared. Oh, 2t squared, sorry. 1 minus t squared for 1 plus t squared squared. This t times 2t is 2t squared. Never mind. Okay, so that's my velocity. Now my acceleration, x what's the derivative of that? Okay, so chain and power rule put together. Let's see. It's going to be minus 2. No, it's going to be 2, sorry. Sorry about that. Now, where were we? Okay, it's going to be gf prime, so that's 1 plus t squared squared times the derivative of 1 minus 2t, which would be minus 2t minus, let me see, 2 times 1 plus t squared to the 1 power times the derivative 2t times 1 minus t squared over 1 plus t squared to the 4th. Now, let me double check that. Yes, that's right. So, what can I factor out? Now, here, being able to factor stuff out will save time and energy. Notice there is a 1 plus t squared in all these terms, so I can factor one of these, I can cancel that, reduce that to 3. Now I have, what else do I have? I have 2t 2t and a minus and a minus. So I can factor out minus 2t. And the first part is 1 plus t squared. Let me see. That is, I got rid of minus 2, so that's plus 2 times 1 minus t squared. 1 plus t squared cubed. Let me see, I'm simplifying this mess. Minus 2t, 1 plus t squared, plus 2 minus 2t squared. 1 plus t squared cubed. Now, so that becomes minus 2t, 1 is just 3, minus t squared, 1 plus t squared cubed. Okay, now, just stop and double check that. Lots and lots of work, doable, annoying, but doable. So acceleration, with respect to time. Minus 2t times 3 minus t squared. So here, either minus 2t equals 0. So remember, we're solving when this equals 0. So time is 0. Or 3 minus t squared is 0. T squared is 3. T is plus or minus the square root of 3. And yes, the restriction is time is 0 to 4 seconds, so we can't do negative. It has to be plus square root of 3. So 2 times acceleration is 0. At 0, time is 0, and time is root of 3. Now, going on to the graphs. On the same axis, 1, 2, 3, 4 seconds. Now, the first thing is time, displacement, x of t. And that should look something like this. Oh, sorry. No, we'll leave it like that. Your graphing calculator. Well, you have to put it in your calculator's x over 1 plus x squared. Remember to use brackets. I shouldn't call it t. Now the next one, velocity. Let me see. Goes something like this. I'll do purple instead. Acceleration. There's something like this. And yes, thankfully we have graphing calculators to do this. In the good old days, we do this by hand. One of the other circles of heck. Now, a couple things to note here. Notice this is to the 1 power, or if we wrote it, it would be a minus 1 exponent. Then we have a minus 2, we have a minus 3. So every time we take a derivative, we're going down a power. Okay, and notice right about a root of a third, we end up with the velocity and accelerating crossing. Actually, no, sorry. No. Wait. Root of a third, the acceleration is 0. What am I smoking? Velocity acceleration. Never mind. So at about a third of a second, square root of 3 of a second, I should say, the acceleration is 0. Now, using this graph, it's helpful. Figure speeding up. Remember what I said about speeding up? Velocity and acceleration, same sign. Same direction or same sign. That is, they're both positive or they're both negative. So, here, note the velocity at 1 second is 0. Now I can prove that graphically, or algebraically. 0 is 1 minus t squared, 1 plus t squared squared. I should prove this algebraically. Now, multiply both sides by 1 plus t squared squared. We have 0 equals 1 minus t squared. T squared equals 1. T equals plus or minus 1. Has to be plus 1 because minus 1 is outside of our domain. So we have, let's see, velocity and acceleration, same sign. Let's see. They are both negative from 1 second to root over 3 seconds. So it's speeding up. 1 is less than time, less than 3. Now, from the graph, you should be able to see that between 1 second and root of 3 second, they're both negative. Before a second and after root 3 of a second, well, before a second, velocity is positive and acceleration is negative. After root of 3 seconds, the acceleration is positive and the velocity is negative, so it's slowing down. So, slowing down. And root of 3 to 4 seconds, slowing down. Less than or equal to, because that's our domain. All right. So, that's the basic idea, doing derivatives. Now, a fair number of questions I'd like you to try. Page 124. 1 to 9, page 128, numbers 1 to 9. Give it a try, please, and good luck.